Hi, my name is Dan Dubin, and this semester I worked with Cheyenne Button and Emily Johnson to optimize FedEx Supply Chain's pick line for small consumer electronics at their distribution center in Dallas, Texas. FedEx Supply Chain, formerly known as Genco, is a third-party logistics provider offering services in warehousing, reverse logistics, people building, and software to execute services on behalf of their customers. Currently, they have 90 facilities across all of North America, with 14,000 employees and 40 million square feet of warehousing space.
This graphic from FedEx Supply Chain illustrates the web of services offered to their customers. This includes warehousing, transportation, commerce enablement, supply chain solutions, and reverse logistics. After talking to our sponsor, we developed a problem statement based on their facility's needs. Their main problem is that the stock keeping units at the warehouse have proliferated by a factor of 2 to 3 since the inception of the initial line, therefore the pick line is being expanded to accommodate the increase in capacity. Our goal is to develop a reslot map to optimize the pallet and case flow across the distribution center by minimizing box recirculation and replenishments.
Here you can see an entire plant view of the pick line, where the right is the north wall and the left is the south. Empty boxes will come in along the conveyor on the north wall and split to head south on the conveyor through the zones. As the boxes head south along the first conveyor line, the label is scanned at each zone for the relative SKU stored in that zone. If the scan is negative, the box continues on the line. If it's positive, then the box is diverted into that pick zone. Once the SKU is placed in the box will return to the line and continue the same procedure. If the box is picked complete at the end of the first line, then it exits at this yellow exit point. If not, the box continues over this incline to the second line, where it follows the same process as the first. Once the box completes the loop, the box exits at the second exit point at the end of line 2. If the box is not picked complete, it loops around again following the same procedure. When the boxes have been successfully filled, they will travel along the topmost conveyor where they will be finalized, scanned, sealed, and shipped. By the end of this project, we promised FedEx Supply Chain 3 deliverables. First, we will recommend the location of product within the zones to balance the zones and maximize pick completion within the first loop. Second, we will define the optimal number of pick bins per storage type, whether that be case or pallet flow, within each pick area to minimize replenishment. Lastly, we will establish the need and quantity of dynamic pick locations to handle any pushed SKUs.
In order to transform the large amount of data into a manageable format, we sorted by columns using RStudio and SQL. Looking at the 3 main deliverables, we sorted the SKUs by highest each quantity demanded, unit per case, and order number. These 3 columns help us to group SKUs into families and identify trends so that assigning slots on the line can be done strategically. What we did with these outputs is discussed next in methodology. After researching various slotting strategies, we decided on a combination of class-based storage and the Pareto rule with some randomization. Our goal is to increase throughput by assigning the most frequently requested SKUs to the zone storage on the line. We started by sorting all SKUs or part numbers based on each quantity given to us in the data file. These top demanded SKUs will be located on the line for picking rather than in off-zone or offline storage. Our assumptions included defining the case flow and pallet flow zones. 8-foot pallet bays are 2 pallets across and 2 deep. 12-foot pallet bays are 3 pallets across and 2 deep. There are 92 zones in total, 88 being 8-foot pallet bays and 4 being 12-foot pallet bays. We are working off of the assumption that replenishment occurs when half of these cases or pallets are used. Replenishment occurs daily between 12:30 a.m. and 7 a.m. Furthermore, 1 slot is equivalent to 8 cases. This is based off of there being 28 slots in each case flow zone, and they are 8 cases deep. Each pallet flow position has 1 level of case flow above it, and these will be used for dynamic pick zones. To assign pallet flow zones, we looked at the top 35 SKUs in October, November, December, and January individually. We used the top 360 SKUs from each month to assign case flow zones. September is excluded based off of the assumption that it can be considered an outlier. Demand is extremely high during the month of September due to iPhone revealings and new product launches. Thus, the September data is used for assigning dynamic pick locations. The idea of using these top 360 SKUs from each month to assign pallet flow versus case flow comes from a heuristic in determining the combination of pallet versus case flow zone storage in order to maximize the volume of SKUs represented on the line. This was done by taking the top SKUs in the previously mentioned 4 months, averaging the SKUs each quantity, finding the corresponding unit per case value, and then calculating the number of cases required to fulfill that each quantity demanded per month. The calculated number of cases is divided by 20 in order to find the number of cases needed for daily replenishment. This is assuming 4 weeks in a month, 5 work days, hence 20 days per month. Based on this, we recommend that FedEx Supply Chain use dynamic slotting for the month of September because of the extreme jump in demand levels due to new releases such as the iPhone. These dynamic pick locations are assigned to the case flow slots above the pallet bay zones. The case flow slots are 6 cases across and 8 cases deep. With 32 assigned pallet flow zones, there are 192 slots total for dynamic storage. For all months except September, the slots will be used to store the lowest demanded SKUs. In September, these slots are reassigned as highest demanded SKUs. This is utilizing a shared stored model technique. Using the slotting techniques previously mentioned, we determine the ratio for pallet flow versus case flow that fits best is 32 to 60. 32 zones are pallet flow and 60 are case flow. In total, there are 1,031 SKUs represented on the line. These SKUs were taken from the 360 highest demanded SKUs from each month. The pallet flow was assigned strategically, looking at order number and quantity, while the case flow was randomized due to the volume of SKUs.
Throughout our time working on this project, we have received help from several influential people. We would like to thank Dr. Louis Loenkesorn, Kevin Bryson, Matthew White, Dr. Brian Norman, and Andy Hunter for all of their assistance throughout the semester.